Now let's consider an equilibrium problem using a base. And let's just choose ammonia. It's a common base, and it's a weak base, so it will produce an equilibrium in water between ammonia and the ammonium ion and produce the OH minus ion. So we can write the Kb for this reaction. And now let's say we start with a concentration of ammonia in water. So I'll use the subscript 0 for initial concentration. Let's say 0.01 molar. We want to find the pH of the solution. So with any equilibrium problem, first we define an extent of reaction. So we'll let X equal to the amount of ammonia that reacts, and therefore at equilibrium our concentrations will be initial concentration of ammonia minus the amount that reacts, and NH4 plus concentration at equilibrium will just be X, and the OH minus will also be X. So putting that into my Kb expression, I'll get X squared over 0.01 minus X. And then collecting terms, and solving the quadratic expression, and looking at a table, Kb is equal to 1.8 times 10 to the minus fifth. And therefore I put that in for Kb everywhere in the quadratic expression it appears. And solving the quadratic expression will give me these two roots for X. I'll get a negative root, and I'll get a positive root, and so since X is the concentration of NH4 plus and OH minus, it has to be positive, and therefore only the positive root is physically meaningful. That means the concentration of OH minus is equal to X, which is 0.00042 molar. Now, we want the pH, and so we need the H3O plus concentration, but we can use the Kw equilibrium, which is always valid in water, to get the H3O plus concentration from the OH concentration. So at 298 Kelvin, Kw is always 10 to the minus 14th. So that will give me the H3O plus concentration of 2.4 times 10 to the minus 11th molar. So now I can find the pH, just the negative log of that concentration. Which will be 10.6.